Hey, what's up guys? Today we're going to look at resistor networks and how we can calculate the total resistance of resistor networks. In previous videos, we've looked at how we calculate the total resistance of resistors in series. So here I've got three resistors, R1, R2, and R3. And we can see that in series, the total resistance is simply R1 plus R2 plus R3. When we have resistors in parallel, it's a little bit more complex. So here are three resistors in parallel, R1, R2, and R3. To calculate the total resistance here, you have to do 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And you just repeat this on both sides for however many resistors you have. But that was looking at isolation with resistors in series and resistors in parallel. Today we're going to look at networks of resistors. And in these networks of resistors, you could have some resistors that are in parallel. So here we've got a 20 and a 30 ohm in parallel. And we've got 10, 25, and 15 ohms in parallel here. But these two combinations are in series with each other. So we're going to learn how to apply the rules for resistors in series and the rules for resistors in parallel to these resistor networks. So let's do some worked examples. So the first one, what is the total resistance of this network of resistors? We've got a 50 ohm in series with 200 ohm and 150 ohms, which are in parallel with each other. Whenever we do this, the secret to all of this is to simplify the circuit. And you always start off by doing the resistors that are in parallel with each other first of all. So let's calculate the total resistance of these two resistors. Because they're in parallel, we do 1 over RT is equal to 1 over R1 plus 1 over R2. So we simply do 1 over 200 plus 1 over 150. And we get 1 over RT is equal to 0.0117. Therefore, RT is 1 over that. You have to remember to do the reciprocal, 1 over that answer to get your final resistance. So RT is simply 85.7 ohms. But we've only calculated the resistance of this part of the network. But we can replace that part of the network with this total resistance. So we now have 85.7 ohms. So this process, we've simplified the circuit. And now we've just got two resistors in series. And we can use our formula for resistance in series. RT is equal to R1 plus R2. So the total resistance now is simply 50 ohms plus 85.7. And we have a total combined resistance of 135.7 ohms. And that's the total resistance of this complete resistor network. So the method that we used there was start off with the parallel components of the network, simplify it down, and then add the resistors in series once you've simplified. Let's follow that method again. So here we've got a 20 ohm resistor in series with a 30 ohm resistor and a 10 ohm, but we've got a 50 ohm and a 40 ohm resistor in parallel. So we always start with the parallel part of the network. So starting there, we say 1 over RT is equal to 1 over R1 plus 1 over R2. And that gives us 1 over 50, because we're looking at this resistor, plus 1 over 40. Therefore, 1 over RT is simply 0.045. When we do the reciprocal to work out RT, we do 1 over 0.045, excuse me. Therefore, RT is simply 22.2 ohms. Once we've calculated that parallel part of the network, we simplify our circuit. So we've got 22.5, and you can see here we've simply now got 4 resistors in series. So RT is now R1 plus R2 plus R3 plus R4. And we just put in our numbers, 20 plus 30 plus 22.2 plus 10. And the total resistance of the network is 82.2 ohms. And there we have it, completed. This one is our final one that we're going to look at. What is the total resistance of this network of resistors? We've got two parallel circuits that are in series with each other. So we've got this component, which I'll call A, which has got 10 ohms, 25 ohms, and 15 ohms in parallel. And we've got this component of the network, which is also in series with A, but we've got a 20 ohm resistor and a 30 ohm resistor. So we always start off with the parallel components and we simplify them down so we can get a simple series circuit. So let's start off with part A. 1 over R1 is equal to 1 over RT, is equal to 1 over R1 plus 1 over R2 plus 1 over R3, which gives us 1 over 10 plus 1 over 25 plus 1 over 15. Therefore, we get 1 over RT is equal to 0.207. Therefore, RT is the reciprocal of that, 1 over 0.207. So RT is 4.83 ohms. And I'm going to put it in my simplified circuit here so I remember later. Now we look at component B, this next parallel part of the network. We do the same process again. Resistors in parallel, 1 over RT is 1 over R1 plus 1 over R2, which gives us 1 over 20 plus 1 over 30. And therefore we get 1 over RT is 0.084. We remember, as always, to take the reciprocal. So RT is 1 over 0.084 and RT is 12 ohms. So we now put that in our simplified network. Now we've just got two resistors in series. So the total resistance is R1 plus R2, which is 4.83 plus 12, which is 16.83 ohms. It's really, really easy. We just keep following the method. So in summary, resistors in series, the total resistance is R1 plus R2 plus R3 and so on. When we have them in parallel, we have to do 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3. When we have a network of resistors which have resistors in series and in parallel with each other, we've just got to follow a simple method. Calculate the total resistance of resistors in parallel. Then you can simplify the circuit into a series circuit. Then you calculate the total resistance using the formula for resistors in series. And you can't go wrong. That's it. Thanks for listening. See you all soon.